Hello physics students, Mr. Fugit here. Today we're going to be discussing what you all work through in either lab number 6 if you all are in physics, or in lab number 1 if you are in the STEM class. And this is the activity where we went outside, took the protractor tools, and we used those to measure an angle as well as a distance, and we used that to predict the height of the building. What I noticed as I was looking through a few of these different activities was that some of you all were getting some fluctuating values, and there were a few questions as to how we should be getting the right value. So I want to take a few minutes to clear that up just so we have good clarity on what we should have been seeing. So in general, here's what we were gearing towards outside. Our goal was to try and predict the height of the front addition of Edmond North. I'm going to call that value y, the height of Edmond North. Now, as we discussed in class, you were actually measuring this value y from your own eye height. So after we went through and we found this y value, you added that into your eye height. So for the purpose of what we're going to be talking about now, we're just going to look at how to use the data we recorded to find the y value. Okay? The eye height, I believe, was a little bit more straightforward. So what you did was that you all were to take measurements of an angle at a certain distance away from the building. I'm going to call that distance d and label it down here in red. Now, the distance value is going to change. You all recorded data at things like 10 meters, 20 meters, 30, 40, and all the way up to 50. For right now, to keep this uniform, I'm going to refer to that generic distance value as d. Now, we modeled this, y and d, as a right triangle, meaning we can use our different trig functions. And the angle that we measured on our protractor was this angle in the top right corner, which we referred to as theta. And so it was your job to take the d value that we knew, those were marked 10 through 50 meters, and the theta value that you recorded up here, and use those, along with what trig functions we knew, to solve for our y value, or the height of the building, if you will. Now, you'll notice here, we had a theta value and a d value, and we're looking for y. So with an angle, the adjacent and opposite sides, that's probably going to be our tangent function. If you'll remember, the acronym we've been using is SO, CA, TOA. And then that tangent function, that's a function that relates the opposite and adjacent sides of any right triangle, which is what we're going to use here. So to set up the expression for what we can use to solve for y, let's come to a new page. So, now that we're here, I'm going to set up my equation for the tangent function. And I'll really quickly redraw my triangle so we can have a reference value here. We said that y was effectively our y component, the height of the building. D was our horizontal distance away from the building. And our angle in the top right corner was theta. So, according to my expression for tangent, it should look like this. Tangent of my angle theta is equal to opposite, so across from my angle is going to be my d, which would be the horizontal component, and adjacent to my angle, is the y value. Now, if you remember, we're solving for y. We're trying to get this variable by itself. So what I'm going to do here is I'm going to multiply by y on the right side and the left side of my equation here. Remember, that equal sign in the middle means that whatever I do to one side, I have to stay equal on the other. So if I multiply by y on one side, I have to multiply it by y on both sides. That should get this y value to cancel out for me. And my expression should become something that looks a little bit more like this. Get rid of these y values over here on the right. Lost my eraser, I apologize. Okay, so our function should look a little bit like more like this. I apologize for the delay. Y tangent of theta is equal to d. Move this down just a little bit so we have a better picture of it. Now, if you'll remember, what we're looking for is our y component, or the height of the building. And if we look at our equation now, y isn't quite by itself yet. So what I need to do is I need to divide by tangent of theta in order to get my y value by itself. So dividing by tangent of theta, notice we're not applying an inverse. We're not undoing our tangent function. We're just simply moving it to the other side of our equation. That should get rid of the tangent function on the left side of my equation. So in order to get rid of that, I will erase it so that it clears things up just a little bit for us. And I should have an expression that looks a little bit more like this. My y value is equal to d divided by tangent theta, where d is our distance from the building, and theta is our angle measured, and y would be our height of the building. One of the common misconceptions that I noticed was that some of you all did not move the tangent theta back underneath the right side of our expression. And some of you all had an expression that looked a little bit more like y is equal to d multiplied by tangent theta, which is why your values would have been increasing. Hopefully after this explanation you're feeling a little bit more comfortable with how to get there. We're just taking the angle that we know, a trig function that is tangent, and using that to relate two sides of our triangle. If you have any questions, don't hesitate to ask. I'd be happy to answer them. Best of luck.